Okay, this is an addendum to the previous video where I showed the demo of the end-to-end of Moneysocket. This is a deeper dive into what I have proposed here as a beacon. So it's this Betch32 string. So I'm going to talk about what's in there. So this terminus provided this beacon, and what's encoded in the beacon is that it wants to be connected to at this host and this port. So I could paste that in here and decode it, and you'll get a shared seed, and then there's a WebSocket type, and then the host and a port, and whether there's TLS or not on that. But these can be encoded. They're either way. I've got a compatible Python and JavaScript implementation. So you can connect to a host. I have this cloud relay set up such that these browsers can connect to each other easily. So it's just running on AWS Cloud, and the host is relay.socket.money, which whatever service could choose a different relay should they want. But what you get there is and so if you take that and you paste it there and decode it, you get back out what came in. So it includes this random seed. So this is a value that once you've shared the beacon, you've also shared this seed. So this gets used as the basis for the rendezvous. And then also once the rendezvous is established, once these two peers have found each other, it derives from that AES encryption key. So then the session proceeds encrypted such that the relay doesn't actually see what's being exchanged. It just sees ciphertext. So the protocol has built into it the escalation of we start do the rendezvous in clear text. Once we've established a rendezvous, then it will then proceed, like the relay will just forward from there, and it'll just proceed in ciphertext. So the way briefly that works, you have the shared seed, which is 128 bits, which comes from here. I double SHA-256 that to get the AES key, and then I double SHA-256 that to get the rendezvous ID. I don't know if this is the best scheme. If you have different ideas, it's certainly flexible if we have better ideas. So these connect into the relay, and it says, hey, here's my rendezvous ID. Once the relay has two peers, it says, okay, you two are peered up, and then they can start exchanging. So what we can do, so this guy could generate, so this, if I copy the beacon, it's got its shared seed, so I can go connect into the relay, and then I can copy that and paste it over here, and then these guys can go find each other. Now this didn't fully connect because this guy doesn't actually have a downstream guy yet, so it's still in the orange state. So after it rendezvous, then it has to do a wallet handshake, and this hasn't completed the handshake because this guy isn't fully healthy as a wallet yet. So to make him fully healthy, I can take the terminus and place it there, and then we get a fully connected system here where I went through all this on the demo. But yeah, this also has the property that if your one end of this disconnects, this other guy still has the WebSocket up to the relay. So if this guy comes back later with the same beacon, they can reestablish the connection. So this is perhaps a way around the fact that maybe your phone has to go to sleep and it loses the WebSocket connection to your home. But then when your WebSocket, or when your phone turns back on, it says, okay, I'm going to reestablish that WebSocket connection. I'm going to rendezvous with whatever I have listening at home. I can even show that. So in this terminus, I can clear connection on wallet 0, and then I can go connect. So instead of this guy listening, I can have this guy connect outgoing to the relay, which I just have some clipboard trouble here. So rather than this guy connect down to the thing, this guy can connect up to the cloud and rendezvous with this guy. So like I said, if this disconnects, you can remember what his beacon was, and then find his terminus then at a later date. So that's WebSocket. But the vision of this beacon stuff is to support more than one interconnect. So I just drew this kind of brief picture here. If you have a peer device and a peer device, here I have them connect into relay.socket.money. Of course, any service could provide their own relay. It's actually better if it's not like a single point of failure. So it's going to be open source software. Anybody can run a relay. It's not going to be lots of bandwidth to provide this service. But yeah, that's at least it's a high, like these pings here are about 100 milliseconds. I'm not in a city that's known for its ping times. This is like to the West Coast U.S., which is a fair ways away from here. So it's about 100 milliseconds. So that'll at least work in most firewall circumstances. Also, like I showed the WebSocket Direct, where if I'm within my home network and I want to connect my device to my node, which is on another machine within the LAN, WebSocket Direct is going to be a very good thing. However, it's kind of difficult to go set that up with the right settings, and then TLS is a problem if you don't have a cert, which you probably don't on your home network. So this really isn't ideal. I mean, it will work. It's good for like infrastructure applications, like within your backend. You probably WebSocket Direct is just fine. But really what we're heading towards is like a metaphor of like a phone call, where I turn on my wallet and it calls home to wherever my node is, or it calls home to whatever my custodial service is. Or even within the phone, it can then do like a localhost connection to a different wallet app to access the balance. But yeah, the idea is, we want to support a bunch of these interconnects, and then WebRTC I think fits very nicely into that, to sort of that call metaphor, where I want to call home and I want it to figure out the best connection for me to get home. So we can provide, in the same way I have a relay, we could provide a turn server, a stun server, such that in the beacon it's like, here's my phone number. Call me if you want to access this money, and so then it'll do that through WebRTC. If I'm understanding how that works yet, I haven't actually gotten my hands on WebRTC. But yeah, so I think that's a pretty good style. I think that's what WebRTC is designed for, is to get around this like relay versus direct kind of trade-off. It'll find the best effort. Turn WebRTC. It basically fails back to this. Which sucks in video conferencing, because then whoever's on the server has to like pay for all that bandwidth. But I don't think it's a big of a deal here, because the bandwidth of actually exchanging bolt 11s and requests and all that is not a huge amount of bandwidth, I don't think, unless if this takes off massively, in which case hopefully I'm getting donations to actually run the server. But yeah, then also other styles of interconnect, like Bluetooth. Like if you have a device that can advertise it, or even in the web browser, there's like web Bluetooth. So if you want like a high quality link from your browser to your phone, your web browser can. I don't think it's a very well adopted standard at this point. It's still fairly new, but yeah, perhaps the web browser can access Bluetooth, or whatever you're doing can access whatever Bluetooth hardware is and get a Bluetooth link that's low latency. And then NFC, perhaps NFC is useful for exchanging the beacons, but it's not unthinkable. Like NFC does have two-way communication possible. So like if you had some application where you like had to put your phone down on the table and could get an NFC connection with that, from your wallet to whatever's built into the table, then it could provide. And even though that's kind of janky tech, it has a good security kind of feel to it. Like QR codes are good because they feel secure. NFC is another one of those. Like even though it's limited, it feels secure. So I think that's something we got to consider too. And then I don't know about like TCP sockets or domain sockets. I'm not sure how mobile development works for if you want to find a wallet that lives on the same phone as the application you're trying to use. Whether a domain socket or just like a local host, direct WebSocket connection is possible. But yeah, I think all of that's in scope. I'll just show to finish off here. I do the way the JavaScript and the Python implementation. I do have it encoded with placeholders for WebRTC and Bluetooth and NFC. So if I take one of these and I decode it. it has multiple locations. So it says, you know, I prefer you connect here, but maybe you could connect also WebRTC. Maybe you could also collect Bluetooth. Perhaps there's multiple WebSocket locations, one that's close, one that's far, one that's on localhost, one that's in the cloud. And then within the beacon, it can kind of rank what its preference is of how whoever gets that beacon can go connect in. So I believe, yeah, it's fairly flexible. There's a lot that can be done, open to suggestions, and yeah, we just need to iterate and then do a research on these various transports to figure out what makes sense. And then at least, even if we don't support this, as this protocol gets off the ground, to make it extensible. So I did this encoding in a way that's extensible. I actually used some of the TLV stuff in Bolt 1 in the Bolt specs. So I have a JavaScript and a Python encoder and decoder of the TLVs. And that's just following along what Bolt 1 and what they're doing with the TLVs to kind of allow extensions to the protocol in a non-disruptive way. So I'm kind of incorporating some of that wisdom here in this protocol. So if you have any feedback of how we could do this better, or different ideas and all that, yeah, certainly this is ready to flex. Okay, that's over 10 minutes. So yeah, thanks for listening. See you in the Telegram.